All right, so we're going to do 8.5 and part of 8.6 today, power series. Power, power, power. No. All right, so a power series is a series of the form sum as n goes from 0 to infinity of c sub n times x to the n. So we'd have c sub 0 times x to the 0, which is just 1. That's why it's not written there, plus c sub 1 times x, plus c sub 2 times x squared, plus c sub 3 x cubed, plus, and it goes on forever, where x can be any variable, and the c sub n's are constants called coefficients of the series. All right. For any power series, our main interest is for what value of x is that series convergent or divergent. With that initial example where we had c sub n times x to the n, if all of our c sub n's were 1, then the series is actually geometric, because we go 1x, x squared, x cubed, x to the 4th, all addition. So our a is 1, the r value is x, and we know from our work with geometric series that that will converge as long as the absolute value of x is less than 1. In other words, if x is between -1 and 1. In fact, we can represent that series with a function. And so we said this was 1 plus x squared plus dot, 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 dot. And the function that we can use to represent that is actually the formula for the sum of a geometric series. It's a over 1 minus r. So anytime you see a geometric series, and if you're asked, well, represent that as a function, it's just going to be a over 1 minus r. Have they done that on the AP test in the past? Yes. Not every year, but it has been done. All right, so we get something like this. For what value of x is the series, the sum n equals 0 to infinity of n factorial over x to the n? For what values of x is that series convergent? And to figure that out, we are going to use the ratio test. which was talked about on Tuesday, Tuesday. So the ratio test says take the limit as n approaches infinity of n plus a sub n plus 1 divided by a sub n. And we know we have a convergent series if the ratio test gives us a value less than 1. So what we'd really like to do is simplify this. And n plus 1 factorial is n plus 1 times n factorial. It's n plus 1 times n minus 1 times n minus 2, all the way down until we get to 1. X to the n is x to the n times x to the first, I'm sorry, x to the n plus 1 is x to the n times x to the first. In the denominator, we have that n factorial and x to the n. And look at that. All sorts of things cancel out. So we end up with the limit as n approaches infinity. Wow. Of the absolute value of n plus 1 times x solving that to get the x by itself, I divide both sides by n plus 1. I don't have to worry about n plus 1 being negative. First of all, it's in absolute values, so that's nice. Second, we know n in this case goes from 0 to infinity, so we don't have to worry about negative values. I'll bring the limit along just to. As n goes to infinity, what happens to n plus 1? Boy, Mr. Gingrich, it goes to infinity too. Golly gee, you're right. And what is 1 over infinity? If you take 1 and divide by a really, really big number, yeah, it approaches 0. So this is convergent. I shouldn't have equals there, sorry. The only time this is convergent is when x is 0. And that's a pretty boring series. Because what is that series? 0 plus 0 plus 0 plus 0 plus 0, boring. But that's the convergence. All right. One that might be a little bit better. For what values of x does the series n goes from 1 to infinity, x minus 3 to the n divided by n converge? So again, starting by looking at a sub n plus 1 divided by a sub n. I'm going to rewrite that division because we have rational expressions there. That's the same as x minus 3. That 3 looks very bad. To the n plus 1 over n plus 1. Times n over x minus 3 to the n. In this case, n factors of x minus 3 cancel out. So I'm left with one factor of x minus 3 in my numerator. Does that make sense? Okay. How about if I write it this way? Go like that. So x minus 3 to the n plus 1 is the same as x minus 3 to the n times x minus 3 to the first. Okay. Now the x minus 3 to the n's pretty clear there that they're going to cancel out. I'm going to rewrite this. I'm going to put all of my, don't let me get sloppy here, guys. I'm just telling you. That's not x going to infinity. That should be n going to infinity. I did have it right once. So I have n over n plus 1 times x minus 3. What happens to n over n plus 1 as n goes to infinity? Let me give you a hint. What about L'Hopital, right? We have infinity over infinity. So what if we take the derivative? What's the derivative of n? Give you a hint. It's a number. It's between 0 and 2. 1, yeah. How about the derivative of n plus 1? 1. So I have 1 there, right? So as n goes to infinity, this thing here goes to 1. And 1 times x minus 3 is just x minus 3. The absolute values just mean that x minus 3 is between -1 and +1. Now, if I add 3 all the way across, x would be, that series, sorry, would be convergent for x values between 2 and 4. So a lot of algebra for these convergence checks. And then some, dealing with limits and remembering what happens for certain values. All right, so there are three things that can happen when we look at a power series. Either it only converges at one value, or it could converge for all values, or there's a range of values for which it converges. And the one that we're really going to focus on is number 3, because that's the most fun. So we did see that x to the n times n factorial converge for a single value. We did see one for number 3 where x minus 3 had to be less than 1. So x had to be between 2 and 4. A series that converges for all values of x, we'll take a look at. I will tell you right now, there is a series that can be written for e to the x, and that converges for all values of x. There's a series for cosine that converges for all values of x. There's a series for sine that converges for all values of x. In other words, all that means is if I take x and plug it into that series definition, I get the exact value of the function. Now it has to go from 0 to infinity or 1 to infinity, but we get the exact value. All right, in case 3, the number r is called the radius of convergence. And there are many times when you'll be asked, find the radius of convergence. In case 1, the radius of convergence is 0. And in case 2, the radius of convergence is infinity.
Can you go back this slide for a second and finish?
1. The sheet that I handed out to you, I think I mentioned that I would hand that out last week in class. It is the different tests for convergence and divergence of different series, and what needs to happen for it to be convergent, what needs to happen, or if it can tell if it's divergent. I think on there is one that we didn't do, and it's not on the AP exam. It's the root test, so you can ignore that one. Otherwise, we've actually covered all of the rest. What's that? I don't think that I would necessarily memorize it. To be honest, I would focus on the ratio test because it's the most useful. From there, it's always a good idea to have another test kind of just in case, because what happens if the ratio test gives you a 1? We're in trouble because we don't know. So I would say ratio test, and then one other, maybe 2 other, maybe like the limit comparison test or the comparison test. They're kind of the same. Integral test is always a good one. All right, so getting back to this one. The interval of convergence of a power series is the interval that contains all values for x for which the series converges. Again, in the case of the first, in the first case, the interval is a single point, a single value. In case 2, the interval goes from negative infinity to positive infinity. Is it okay if I go up like that? All right. In case 3, we need to check the endpoints of the interval because they would make the ratio test equal to 1. And if you remember, when it's equal to 1, we're not sure if it's convergent or divergent. So we check the endpoints, and it's possible that it could converge at both endpoints, diverge at both endpoints, or converge at one and diverge at the other. So we can find the radius of convergence, and from that we can determine the interval of convergence. And again, more often than not, we're more concerned with the interval of convergence. Stretch the fingers out, make sure they're ready to go again. All right. And the test on those endpoints is actually pretty straightforward, as you'll see here. Find the radius of convergence and the interval of convergence for the series, the sum as n goes from 0 to infinity of negative 3 to the n times x to the n over the square root of n plus 1. And again, finding the radius of convergence and the interval of convergence is going to start with the ratio test. So we're going to take the limit as n approaches infinity. And I'm going to write it this way, even though it looks really weird. but I'm plugging in n plus 1 everywhere there's an n. So underneath that square root, I have n plus 1 plus 1. Okay. And we're guaranteed it's convergent if that thing is less than 1. Rewrite that rational expression as the product of the numerator times the reciprocal of the denominator. And you'll notice I already broke things apart. -3 to the n plus 1 is -3 to the n times -3 to the first. X to the n plus 1 is x to the n times x. And n plus 1 is n plus 2. So a couple of things now that we can cancel. And I'm left with the square root of n plus 1 divided by the square root of n plus 2 times x times -3x, sorry. As n goes to infinity, what happens to the square root of n plus 1 over the square root of n plus 2? Goes to 1, right? Again, you could think about L'Hopital, and you'd have 1/2 n plus 1 to the -1/2 times 1, and it works out. So I'm done with my n's. I just have this thing. I would divide by +3. Why am I dividing by +3? Because I have an absolute value there, and the absolute value of -3 is +3, right? So this is the same as just 3x. And now the absolute value allows us to say that our interval of convergence is from -1/3 to +1/3. And now we want to check the endpoints. So to check the endpoints, we go back to our original expression, which was -3 to the n, x to the n over the square root of n plus 1. and plug in negative 1/3 for x. Because I have the same exponent, I can multiply my bases. So negative 3 to the n times negative 1/3 to the n is the same as positive 1 to the n. Is that series convergent or divergent? Hint, think comparison test and power series. This is a p series where p is less than 1. And if p is less than 1, the series is divergent. So negative 1/3 is divergent. Now we still have to check positive 1/3. So negative 1/3 is divergent, so it's just going to stay less than. For positive 1/3, I'm going to do kind of the same thing. We're going to multiply negative 3 times positive 1/3 and take our answer to the nth power. Is that convergent or divergent? Give you a hint. 99 times out of 100, if you have negative 1 to the n, you have an alternating series, so it alternates between positive and negative. It's going to be convergent. Okay. And it's convergent as long as the rest of the sum goes to 0 as n goes to infinity. So that's convergent. So that means we include the positive 1/3. Okay. So our radius is 1/3. Our interval is from negative 1/3 to positive 1/3, including the positive 1/3. So I guess maybe the alternating series test would be another good one to know. It's actually a pretty easy one too. So that's used a lot in finding the interval of convergence. All right. One more. Find the radius of convergence and interval of convergence of the series n times x plus 2 to the n over 3 to the n plus 1. Guess what I'm going to start with? The ratio test. And you know, after you do a couple thousand of these, you just get used to, I'm going to take n plus 1 and multiply by the reciprocal of what I get when I plug in n. Okay, so rather than writing it as a fraction first, just write it as the product of the reciprocal of the denominator. Does that make sense? Okay, all right. And then again, we have some things that cancel. Hopefully we're pretty confident now. We're going to have a factor of n, factor of 3 in the denominator, because the n plus 1 cancels with the n plus 1. We're going to have a factor of x plus 2 in the numerator. And everything else stays. I take the limit as n approaches infinity. N plus 1 over n times x plus 2 over 3. As n goes to infinity, what happens to n plus 1 over n? It goes to 1. Yep. So now I can get rid of the limit and just concentrate on x plus 2 over 3 being less than 1. I'm going to leave the absolute values on until I get that term with just x by itself. So I'm going to multiply both sides by 3. And now I'm going to look at the radius of convergence. So the radius of convergence would be 3. And it would be from -3 to +3. Subtract 2. And we need to check our endpoints. So if I go way back up to my original expression, n x plus 2 to the n, 3 to the n plus 1. Yeah. Plug in -5. This would be n over -3. Ooh, not good. -3 to the n over 3 times +3 to the n. -3 to the n is the same as -1 to the n times 3 to the n. So our 3 to the n's can cancel, leaving us with -1 to the n in the numerator. As n goes to infinity, does that thing go to 0? No, right? Because n's going to get larger and larger. Our numerator is getting larger and larger. Our denominator is staying 3. It's just going to alternate positive and negative values, but get further and further away from 0. This is divergent. And if we check positive 1, and n over 3, because the limit as n goes to infinity, that doesn't go to 0. That's divergent. So there is our interval of convergence. We don't include either endpoint. All right, so what I would like you to do is a little practice with radius of convergence, interval of convergence. Did I time it just perfect? Photobomb. Photobombed.
A lot of this work,
Yeah?
and I promise I am working on it slowly. And it will get done eventually. I just started a new medication. I've been sleeping 15 hours a day.
Oh,
Yeah.
fun.
No, it's not really. Okay. I'll tell you this one, it was convergent. That one,
Okay.
divergent.
So this one is convergent because if I ignore the negative 1 to the n, 1 over the square root of n plus 1, as n goes to infinity, the fraction would go to 0. And part of the alternating series test is, if it's an alternating series, so if you have negative 1 to the n, and the terms go to 0, it's convergent. This one, n over 3 does not go to 0. As n gets larger and larger, n over 3 gets larger and larger.
Yeah, okay.
So that's why it's divergent. It's a good question. And unfortunately, I feel like I'm sprinting, and I can only imagine you feel like you're sprinting as well.